I, I who have nothing, I, I who have no one.
Section 3.2 is on the law of sines. It's also called the sine law. And we're going to start today working with triangles that do not have right angles, non-right angle triangles. There's a special name for those triangles, and here it is, oblique triangle. An oblique triangle is a triangle that does not contain a right angle. And when we did trigonometry last year with sine, cosine, and tan, we said that the triangle always had to be a right angle triangle in order to use those three ratios, sine, cos, and tan. But this year we're going to learn some new laws, the law of sines and the law of cosines, that we can use even if it's not a right triangle, if it's an oblique triangle. So we can solve a triangle, all the sides and all the angles. We can find all those things out in any of the following 5 situations. And I have 5 triangles here, and they're not supposed to be right angle triangles. It kind of looks like a right angle triangle up there. Whoops. Pretend that's not a right angle up there, okay? I don't think it actually is. So one way you could solve everything in a triangle, in a non-right angle triangle, is if you knew an angle, another angle, but it's not necessarily the same amount. So I'll put 2. I'm just showing you that if you knew this amount here and you knew this amount here, and they're not necessarily the same, that's why I put 2 of these arcs here to show it's not necessarily the same as that. And if you knew the side in between them. Now, there's a special name for this. This is called angle because you know one angle. Side because you know the side in between them. Angle. And there's a faster way of writing that. It is just ASA. Angle, side, angle. Okay? If you knew that, you would be able to solve the whole triangle. If you knew, for example, this is 40 degrees, this one over here is 38 degrees, and this one here is 16 centimeters, then you could solve the whole thing. Okay, another situation you're able to solve is if you know this angle, or any of the angles, really, I'm just giving an example here. And again, you know one of the other angles, let's say this one this time, and you know one of the sides, let's say this one. Now, you might look at this one and say, well, it's exactly the same as last time, you know, 2 angles and a side, so it's angle, side, angle again. But this is not angle, side, angle. Do you see why? Because in this case, the side was between the 2 angles. This side is not between the 2 angles. The side that's between them is this one up here. So this one is called an angle, angle, side. I suppose you could also call it side angle angle. Now, we could solve this because if we knew these 2 angles, we could very, very easily get this third angle here, because you know that all 3 angles in a triangle add up to 180. And once you had this angle here, you'd be back to an angle, side, angle. So really, an AAS, an angle, angle, side, can turn into an ASA, which we've already said we're able to solve. Okay, and just to make it crystal clear, I'll write where this angle is here. I'll put confined since the 3 angles add to 180 degrees. And remember, that's true in every triangle, not just right angle triangles, every single triangle. Okay, the next one, I mean, there's no particular order, but another situation where you can find out everything there is to know in a triangle, solve the triangle, all sides, all angles, is if you know, for example, this side, and this angle, and this side. So what kind of situation is this? This is a side, angle, side. The angles between the 2 sides. So side, angle, side you could solve. Next one we'll look at is this one. You know that side, you know that side. Not necessarily the same, so that's why I put 1 tick and 2 ticks and 3 ticks. So you know all the sides. What's that called? Well, it's easy. That's a side, side, side. Okay, these 2 here we will not be dealing with today because you cannot solve using the sine law. You would need to use the cosine law, which we'll learn next day. Okay, and the last type that you could solve, the last type of triangle you could solve completely, is if you had this side and this side, or any 2 sides, doesn't have to be these 2, and an angle here. So is this, well, what's one possible name for this? One possible name is side-side angle. That's the way most people call it. Or if you think about it, you could also call this angle side-side, and that's the way I prefer to call it. Now, why do I prefer to call it that? Is it because I'm just very juvenile and like bad words? Well, a little bit. But the main reason I like it is because this type is a pain in the ASS. Why is this one a pain in the ASS? Because this is called, whoopsies, this is called the ambiguous case. And this is quite possibly the most difficult thing you're going to do in this whole course, and we're going to talk about it in the next video. We won't talk about it at all today, and we'll talk about it in the next video. Okay, look forward to that. It's really tricky. Okay, so let's get started. The sine law. What exactly is the sine law? So first of all, let's just draw a triangle, make it a non-right angle triangle, and let's name that triangle ABC. Now, one thing you need to be clear about, I've probably talked about this before, is how you could name all the parts of this triangle. So, for example, this angle here obviously was angle A. This is angle B, this is angle C. But how about this side? How could you name that? Well, you could call it AB, and this would be BC, and this would be AC. Or you could call it BA and CB and CA. It doesn't make any difference. But there's actually a faster way to do it. The angle, the side that's across from an angle takes the same name. So if this is angle A, then this over here is side A, but you use a small a to name it. If this is angle B here, then this is side B, but you use a small b. And if this is angle C here, this is side C, and you use a small c. Okay? Here is the sine law. There's actually two ways of looking at the sine law. One of them is like this. Sine A divided by A is equal to sine B divided by B, which is equal to sine C divided by C. Now, this is weird. It's got two equal signs in here. Okay, so the reason for that is because you're only going to look at two parts of this equation here, this formula here. Okay, for example, I could cover this up, and then the equation would be sine A divided by A equals sine B divided by B. That would work. Or I could cover this up, ignore that, and I'd have sine B over B equals sine C over C. Or I could cover this up, and I'd have sine A over A equals sine C over C. Any of those three equations or formulas I just talked about will work. And when you're going to use this equation, like this formula here, is when you're trying to find an angle. Use to find an angle. And you'll notice in this case all the angles are in the numerator position. They're all on top. Capital A, capital B, capital C, those are the angles on top. The sides are on the bottom. So the thing you want to find goes on top. There's another way of writing the same formula. It looks almost exactly the same. You'll notice it is exactly the same except for one thing. It's the reciprocal of everything. So this time instead of sine A over A, it's A over sine A. Everything is reciprocal, right? Same thing. It could be this, could be the formula. A over sine A equals B over sine B. Or it could be this, B over sine B equals C over sine C. Or it could be this, A over sine A equals C over sine C. Depends what you're looking for and what information you already know. This one you're going to use to find a side length. Okay, now I've said this, it's not totally true. You can use this top one to find a side length. It's just a little more awkward. And you can use this one to find an angle. It's just a little more awkward. So I advise you to do it this way. And the thing you're trying to find goes on top. If you're trying to find a side length, use the small letters on top because those are side lengths. If you're trying to find an angle, use the capital letters on top because those are angles. Okay, let's show you what I'm talking about here. Okay, a triangle's angles measuring 80 degrees and 55 degrees. The side opposite the 80 degree angle is 12 meters in length. Determine the length of the side opposite the 55 degree angle. So we're going to draw a triangle, and don't make it a right triangle because these are not right triangles we're talking about today. Ooh, that's pretty bad. So angles of 80 degrees and 55. Well, this is a big angle. It's probably more than 90, but it actually doesn't matter how bad I drew it. I'll just call it 80, and 55, I'll call this one 55. And what else does it say? The side opposite from 80 is 12 meters. So this is 12 meters. And we want to know the length of the side opposite the 55. We want to know this. So I guess that's my x. But I find it easiest when I do these questions to just label them, name them A, B, C. So it doesn't matter what you call A, what you call B, and what you call C. There we go. If this is A, B, C, what should x actually be called? It's actually A. It's across from the A. So let's put that. That's what we're trying to find, is A. So we're trying to find a side length. So remember, if we're trying to find a side length, what we should be using is this equation right here. We should have the small letter on top. So what you're going to do when you use the sine law is you're looking for pairs. What I mean by that is you've got a pair here. You've got an angle and the side across from it. And you have a pair here. You have the angle and the side across from it is the thing that you want to know. So that's perfect. That's exactly what we want. So the formula we're going to use is A over sine A equals B. We're not going to use C, right? We're not interested in angle C. We're not interested in sine C. We're just going to use B. So equals B over sine B. And then we fill in everything we know. We don't know A. But we know angle A, it's 55. So sine 55 equals B, which is 12 meters, or just I'll put 12. Sine B is sine 80. And guess what you're doing again? You're cross multiplying. So what you want to multiply is this diagonal, since you know you have amounts for both of those. So to get this answer, you will do A equals 12 times sine 55, and then you divide by the one that's left over, which is the sine 80. And you take out your calculator and you do that. I invite you to do that now just to make sure you're doing it right. And make sure your calculator's on degrees, not rad or grad. And when you do that, you'll get an answer that rounds up to 10 meters. Okay? Great. Next one. Find the measure of angle B in the diagram below. So you want to know this angle right here. Remember, you need some pairs. So for this angle B, yes, we have the pair with the side across. And here's our pair here. We have the angle and the side there. So we're good to go. Now, which formula do we want to use this time? This time we want to know the angle. So if you're trying to find the angle, use this one. You want to put the sine A or the sine B or the sine C on top. So what we're trying to find is this angle right here, sine B. So sine B over B equals, not talking about A in this case. We have no interest in A. We're interested in C's. So sine C over C. Sine B you don't know, but we do know side B, which is 9, equals sine C, so sine 80, that's how much angle C is, over 12, that's how much C is. And again, we cross multiply. So you're going to be left with sine B. Sine B equals, multiply those, 9 times sine 80, and then divide by the one left over, divide by the 12. If you do that, you'll still have sine B, and you'll find that it equals 0.74. So we're looking for the angle. So remember, if you're finding the angle, you have to use inverse, right? Fit. This is the fit rule, not the hot rule. This is the fit rule. So angle B equals inverse sine, or arc sine if you want, 0.74. So you go to your calculator and put inverse sine or shift sine or second sine of 0.74, and you should get 48 degrees. And again, I invite you to try that. Alright, last thing, just give myself a little area to work here. Careful output. These ones were kind of the most straightforward questions, the ones I gave you here. But what if you had a triangle like this, and you knew that, let's call it ABC, and you knew this was 45 degrees, and you knew this was 70 degrees up here, angle B, and you knew this was 18 centimeters or something, and you wanted to find side B. So this side down here, if you wanted to find side B. So we said you would do this by finding your pairs. So yes, you have one pair, the 70 and the B is definitely a pair. But you don't have another pair. The 45 degrees does not pair up because we don't know a side there, and the 18, this length here, doesn't pair up because we don't know the angle there. So what are you going to do? You got to figure out how you're going to get another pair. And the way you can easily get another pair is you can find this angle right here, right? Angle C. Angle C is equal to, what do all three of them add up to? 180. Take away the 70, take away the 45, and if you do that, you get 65 degrees. So once you've plugged that in there, the 65 degrees, now you're good to go. Now you have another second pair there, so you can use this form. I'm not going to do it, but what you would do is B over sine B equals C over sine C, and you'd go from there and you get the answer. Okay, so sometimes you do need to do that extra step of finding the third angle before you actually use the sine law. Okay, enjoy today's work. It's not as difficult as next day. Next day is definitely, as I said, perhaps the hardest day of all. Take care.
But believe me, dear, when I say that he can give you the world, but